In a previous section, we wrote a function portfolio cost that read a file, performed a calculation on the data in that file, and did some things like error checking. Just to refresh your memory, this is what the code looked like for that. And when we ran the program, it would produce simple output. What we're going to do here, I'm going to change the program to read the data into a data structure. And the purpose for doing that, I want to be able to do more sophisticated calculations than just computing this total. And so to do this, I'm going to make a few small changes to this function. First thing that I'm going to do is I'm going to change the function into something called read portfolio. So instead of just doing a cost, I'm going to read the portfolio. And I'll change the comment here. Okay, so we're going to read a CSV file with name, date, shares, and price data. Now, right away, we have a problem. What are we reading this thing into? How are we going to store the data? For most problems, you probably want to use something like a list. So what I'm going to do is I'm going to read the CSV file into a list, and I'm going to return that back. The idea is that my list will mirror kind of the structure of that file. So just to refresh your memory, the file looks like that. I'm going to take that file and I'm going to turn it into some list that mirrors that structure. We're going to make a function that does that. Now, in order to do that, here are the changes that I'm going to make. Instead of just calculating a total, I'm going to make a list instead. Okay, so I'm going to make a list portfolio. Okay, this is going to be the list of records, if you will. And instead of updating this total down here, what I'm going to do is I'm going to make some record. We haven't talked about how to do that yet. What we're going to do is append that to the list. Okay, so we're going to make a record and append it, and we'll return the list back. In some sense, it's almost exactly the same as just totaling up those two columns. It's just that instead of summing up numbers, we're accumulating records in a list. That's what we're going to start with. Now, the second problem that we have to deal with is just what is this record that we're going to make? We need to figure out some way to kind of store the information from the file. One of the choices that we might make here is that of making a tuple. Maybe I want to make a tuple that has just the contents of the row here. In some sense, it looks like I've almost converted all the data. It might make more sense to just say tuple of row as opposed to me typing it out like that. Partly because I've already done some of these conversions up here, so it's almost in a form that I can work with. Okay, so I'm going to make a row. I'm going to turn it into a tuple. I'll return that back. Let's just take a look at what's going to happen here. I'm going to say portfolio is equal to read portfolio. And then I'll print that out just to see what happens here. Okay, so I'm going to comment out the other line. What's going to happen if I run this program is I should get a list of tuples coming back. Okay, so you see the file has been converted into these rows. Just to see it a little bit more interactively, if I run this so that I'm back in the interpreter, this portfolio list, if you kind of play around with it, has 7 entries in there. Each entry is a tuple that stores a single row of data out of the file. So this is kind of one way to start with reading data into some kind of data structure. And instead of just summing up a number, we're going to build a list and we're going to add records to that list. Now, in terms of performing calculations with this data, let's just talk about that for a second. By having all of the data, I could redo that total calculation by writing a loop like this. I could say total is equal to 0.0, and then maybe I would say for holding in portfolio, total is plus equal to holding 2 times holding 3. Keep in mind that's shares times price there. Okay, so I can start doing calculations on the data. Maybe I go back to printing out the total cost, write code like that. What's happening there is it's iterating over that list of data and doing a calculation on it. So we're back to where we started, except that we're now working with a data structure. One possible complaint with the code that I've just written is actually this line here. That is not especially readable. At least I don't think it's that readable to have hard-coded indices like that. Kind of reminds me of doing taxes, which is not one of my favorite activities, like line 5 times line 6 sort of thing. So as an alternative, one of the things that you might do is recast this for loop to unpack the variables. So since we have a list of tuples, one of the things we could do is say something like for name, date, shares, price, and portfolio, those variables are going to line up with the different values that you have there. And then I can change the code to look like this. To my eyes, that looks a lot more readable. It should give the same answer. So you get something like that, doing unpacking of tuples. There's still sort of a problem with that, though. One problem with this for loop is that I actually have to unpack all of the values to make it work. Like I have to unpack the name and the date in addition to the shares and the price. Maybe it's not a problem if I only have 4 items of data. However, if this were a file where I had 50 columns or 25 columns or something like that, I would have to exactly match like all 25 columns. And I don't really want to do that. Like I don't want to write a for loop where I list out, 25 variable names if I'm only carrying about 2 of them. One change that you might make to this code instead is a change to what the record is. One of my favorite ways to represent data, instead of using tuples, is to represent data using a dictionary. One of the things that you can do is make a dictionary out of the data, like this. Okay, so what I'm doing here is making a dictionary where I name all of the values, name, row, date, shares, price, row 3, so forth. What's going to happen there, let's just print out the portfolio so we can see the difference in what's going to happen, is you will get a list that has these dictionaries that have been built up. Essentially, every value now has a name attached to it. Like you have date is that, shares is 100, price 32.2. And as dictionaries, I can write the code to refer to those specific keys. I can say for holding in portfolio, total is equal to holding quote shares times holding price. So we're kind of back to code that we had earlier, but what we're doing is referring to these specific key names when we do that. I really like that approach because it makes the code a lot more readable. I can read this, I can see what the different data is. It's also very compact with things like this for loop. I only have to have one variable there. I don't have to worry about unpacking like 20 different values. So this is yet another way of building data structures, maybe a list of dictionaries instead of a list of tuples. One thing that I would kind of note about this last part, building something like a list of dictionaries plays really nicely with other programming languages, by the way. Like here I have this list. One of the things that you might want to do is take that data and ship it off to some other program. Maybe not even in the same programming language as Python. Maybe you want to ship it off to JavaScript or somewhere like that. One of the ways that's commonly used to do that is to use something known as JSON encoding. Turns out that a list of dictionaries works great with JSON encoding. Python provides a built-in library JSON that can be used to do this. And you can take a list of dictionaries and just dump it down into a JSON object. This is something that I could then ship across like a network connection or ship it off to some other program, and then it could decode it. If I ever want to get that data back, there's also a load-s function that can take raw data and turn it back into a Python data structure. So doing things like lists of dictionaries, it's actually often a really good choice for a lot of problems, just because it's fairly easy to create that data structure. It's easy to work with it in terms of simple calculations. And it's also easy to take that data and turn it into other things. So this is often a starting point for working with data. Think about lists, think about tuples, think about dictionaries. You can take the contents of a file, read it into something, and then you can start working with it.